We've been managing software projects the same way for over 20 years. You add a ticket, drag it to a column, wait for verification, drag it again. It's manual, it's slow, it's boring. But what if your project board was actually a completely autonomous engineering team? What if the tickets could debate, plan, and build the software while you watch? Forget the traditional project management tools. Today I'm going to show you a live simulation of a fully autonomous development environment. Using MCP and A2A, these agents are doing the heavy lifting for you. Let's dive right in. So first things first, how does an AI know what's actually on your board? In most apps, the AI is trapped in a chat box. It's like a consultant in a glass room. It can give advice, but it can't touch anything. It can't do anything. If you wanted to know about a ticket, you have to copy and paste the text yourself. If you wanted to move a card, you have to do it yourself. We fixed that with MCP, Model Context Protocol. I'm sure most of you know what MCP is, but for those who don't, MCP is a way for an LLM to connect to external data sources and tools, giving it the ability to actually do things instead of just generating text. In our case, instead of writing custom hooks for every single button, MCP allows us to expose the entire board. The columns, the cards themselves, their tags, as information that the agents can read and interact. Let me give you an example. When the product owner agent wakes up, it queries the MCP server, give me the state of the backlog. As a response, it doesn't get a text summary. It gets the data structure. It sees the board's raw data. And when it decides to do something, it doesn't send you a text message asking you to do it. It calls an MCP tool and does it directly. It literally reaches into the application state and creates the records himself. It's a direct link between model intelligence and the application state. That glass wall we talked about? Gone. But hands are only half the battle. How much can you actually do alone? You need a team, and this is where most AI workflows I've seen break down. They play the telephone game. Agent A does something, summarizes it, passes it on to Agent B, who summarizes it again, and by the time it gets to a later agent, like quality assurance, the context it's gone. We solved this with Google's A2A, Agent-to-Agent protocol. We ditched the telephone game entirely. Now we're playing with context injection. When an agent acts, it generates a structured data payload. It contains all the decisions, dependencies, and code changes. That payload is then injected into the context window of every other relevant agent. They don't need to read chat history to know what happened. They instantly know. They can debate the architecture, spot edge cases, and reach consensus lightning fast. They aren't just talking to each other, they're working together. Let me show you exactly what this looks like in practice. We open Agent-Scrum. The first thing we do is initialize our team. I'll click Start Swarm, and all the agents are brought online and connected. Now, instead of manually writing tickets, I'll just grab my PRD and paste it into the engine. Now, what you've been watching on screen throughout this whole video was this specific PRD being processed in real time. While I was talking to you about A2A and context injection, the swarm was running full speed in the background. We're currently running in simulation mode, so we aren't actually building the app yet, but they are speedrunning the logic. They're finding bottlenecks, defining edge cases, and creating the perfect roadmap so your engineering team knows exactly what to do. This is where software development is heading. MCP gives your AI tools, A2A gives your AI access to each other. But don't just take my word for it, the link is in the description. Go fire up a simulation, watch them talk to each other, and see what it looks like when your software actually works for you. Thanks for watching.